Welcome to a peaceful journey through the cosmos. Let yourself settle in, get comfortable, and allow your mind to drift among the stars. Tonight, we're going to explore the universe in the most gentle way possible, discovering facts about space that will help you relax and let go of the day. Take a deep breath. The universe is vast, ancient, and filled with wonders that remind us how small our worries truly are. As we travel through space together, let each fact wash over you like a gentle wave, carrying you closer to sleep. Let's begin our journey with something truly mesmerizing. Did you know that space is completely silent? There's no sound in the vacuum of space because there's no air to carry sound waves. Imagine that perfect, absolute silence. No traffic, no voices, no notifications. Just pure, peaceful, quiet. The astronauts who've been to space describe this silence as the most profound they've ever experienced. It's a silence so complete that it seems to wrap around you like the softest blanket. Now, picture this. The sun is so large that you could fit 1.3 million Earths inside it. But here's what's truly calming about this fact. Despite its enormous size, the sun is just an average star. There are billions upon billions of stars in our galaxy alone, and most of them are quietly burning away, providing light and warmth to their corners of space. The sun has been doing this for 4.5 billion years, rising and setting with perfect reliability, and it will continue for another 5 billion years. There's something deeply comforting about that consistency, that eternal rhythm. Speaking of rhythm, let's talk about how Earth moves. Right now, as you're listening to this, you're spinning. The Earth rotates at about 1,000 miles per hour at the equator. But you can't feel it at all, can you? You're also orbiting the sun at 67,000 miles per hour. And the entire solar system is moving through the galaxy at 500,000 miles per hour. Yet here you are, perfectly still, perfectly safe, perfectly calm. All that motion, and you don't feel a thing. You're being carried through space on this beautiful blue planet. And all you have to do is rest. Let's drift further into space now. The moon, our closest companion, is slowly moving away from Earth. Just a tiny bit each year, about 1.5 inches. It's been doing this since it was formed 4.5 billion years ago. Back then, the moon was much closer, and the days were only 5 hours long. Can you imagine? Over billions of years, the moon's gentle pull on Earth has been slowing our planet's rotation, making our days longer. It's like the universe itself is telling us to slow down, to take our time. The moon doesn't produce its own light. It simply reflects the light of the sun. On a full moon night, you're seeing sunlight that traveled 93 million miles to the sun, bounced off the moon's surface, and traveled another 240,000 miles to reach your eyes. That peaceful moonlight that helps so many people sleep has taken quite a journey to get to you. Here's something beautiful. Every atom in your body was created inside a star. The iron in your blood, the calcium in your bones, the carbon in your cells. They were all forged in the heart of ancient stars that exploded billions of years ago. You are literally made of stardust. You're not separate from the universe. You're a part of it. You're the universe experiencing itself. When you look up at the stars, you're looking at your relatives, your ancestors in a cosmic sense. Let's travel to Jupiter now. Jupiter is the largest planet in our solar system, so massive that all the other planets could fit inside it. But here's what's fascinating and calming about Jupiter. It's a protector. Its enormous gravitational pull acts like a cosmic vacuum cleaner, attracting asteroids and comets that might otherwise hit Earth. Jupiter has been protecting our planet for billions of years, quietly doing its job, letting life flourish here on Earth. Even the planets are looking out for us on Jupiter. There's a storm called the Great Red Spot. It's been raging for at least 400 years, possibly much longer. This storm is so large that 3 Earths could fit inside it. Imagine that. A storm that's been going for centuries, and it's not slowing down. But here's the thing, it's not chaotic or frightening when you really think about it. It's just the universe doing what it does, following the laws of physics, moving in patterns that have existed since the beginning of time. There's a strange peace in that persistence. Let's slow down and visit Saturn. Saturn is famous for its rings, and those rings are absolutely stunning. But did you know that those rings are made mostly of ice? Billions of pieces of ice, ranging from tiny grains to chunks the size of houses, all orbiting Saturn in a flat disk. If you could visit Saturn and float among those rings, you'd be surrounded by glittering ice crystals, each one catching the sunlight. It would be like floating in the most beautiful snowstorm you could ever imagine, except perfectly silent and calm. Saturn's rings aren't eternal, though. They're slowly disappearing, falling into Saturn as ring rain. Scientists estimate the rings might only last another 100 million years or so. That sounds like a long time, and it is, but in cosmic terms, it's just a moment. Saturn's rings are temporary, a beautiful phase that will eventually end. It reminds us that everything changes, nothing lasts forever, and that's okay. There's peace in impermanence. Now, let's talk about something truly mind-expanding. The universe is approximately 13.8 billion years old. Try to wrap your mind around that number. 13.8 billion years. In all that time, in all that space, countless stars have been born and died. Galaxies have formed and collided. Planets have come into existence and disappeared. And here we are, in this moment, on this planet, under this sky. We're part of an unbroken chain that goes back to the very beginning of everything. You're connected to it all. The observable universe is about 93 billion light-years in diameter. But here's the thing, we can only see a tiny fraction of the total universe. The universe is expanding faster than the speed of light at its edges, which means there are parts of the universe we will never, ever see. There are galaxies, stars, and possibly planets with life that are forever beyond our reach. The universe is keeping secrets, and that's all right. We don't need to know everything. We can rest in the mystery. Let's come a bit closer to home and think about the Milky Way. Our galaxy contains between 100 billion and 400 billion stars. That's a number so large, it's almost meaningless to us. But each one of those stars is a sun, possibly with its own planets, its own story. On a clear night, when you look up and see that band of light across the sky, you're seeing the combined light of billions of stars, all of them so far away that their light has been traveling for thousands of years to reach you. You're looking into the past. The light you see left those stars before human civilization began, before the pyramids were built, before language was invented. Here's a gentle thought. There are more stars in the universe than grains of sand on all the beaches on Earth. Think about that for a moment. Every grain of sand you've ever touched, every beach you've ever walked on, and there, more stars than all of that. The universe is abundant beyond our ability to comprehend. There's enough room for everything, enough stars for every wish, enough space for every dream. Let's talk about black holes, but not in a scary way. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. That sounds frightening, but here's another way to think about it. Black holes are the universe's way of recycling. When massive stars die, they collapse into black holes, and over incredibly long periods of time, black holes slowly evaporate, releasing their energy back into the universe. Nothing is truly lost. Everything is transformed, even in the darkest, most extreme places in the universe. There's a process, a purpose, a continuation. Asterisk at the center of our galaxy. There's a supermassive black hole called Sagittarius, a star. It's 4 million times more massive than our sun right now. It's relatively quiet, just sitting there, holding the galaxy together with its gravity. All the stars in the Milky Way, including our sun, are slowly orbiting around it. We complete one orbit every 225 million years. That means the last time our solar system was in this position, dinosaurs hadn't even appeared on Earth yet. And everything was fine then, and everything is fine now. The galaxy knows what it's doing. Let's drift over to Mars. the red planet. Mars is about half the size of Earth, and it has the tallest volcano in the solar system, Olympus. Mars has polar ice caps, just like Earth in the Martian winter. It gets so cold that carbon dioxide freezes out of the atmosphere and creates a layer of dry ice on top of the water ice. Then, when spring comes, the dry ice sublimates, turning directly from solid to gas, and the ice caps shrink. It's a cycle that's been happening for millions of years. Winter and spring, cold and warmth, contraction and expansion. The universe loves cycles, rhythms, patterns. There's comfort in knowing that everything has its season. Here's something that might surprise you. Venus rotates backwards compared to most planets, while Earth and most other planets rotate counterclockwise when viewed from above the North Pole. Venus rotates clockwise. No one is entirely sure why. Maybe it was hit by something massive early in its history, or maybe its thick atmosphere gradually reversed its rotation over billions of years. Venus does things its own way, and that's perfectly fine. Even planets can be unique. Venus is often called Earth's sister planet because they're similar in size. But Venus is anything but calm on its surface. It's the hottest planet in the solar system, even hotter than Mercury, which is closer to the Sun. The surface temperature on Venus is about 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is 90 times greater than Earth's, like being 3,000 feet underwater. And the clouds are made of sulfuric acid. But here's the interesting thing. High in Venus's atmosphere, about 30 miles up, the conditions are actually quite pleasant. The temperature is room temperature, and the pressure is similar to Earth's. Some scientists think we could float cities in the clouds of Venus someday. Even in the most hostile places, there can be pockets of calm. Let's visit Mercury, the smallest planet in our solar system and the closest to the Sun. Mercury has no atmosphere to speak of, which means there's nothing to trap heat. During the day, facing the Sun, the temperature can reach 800 degrees Fahrenheit. But at night, it drops to minus 290 degrees Fahrenheit. That's a swing of over 1,000 degrees. Mercury experiences the most extreme temperature changes of any planet. Yet, it continues on its path, orbiting the Sun every 88 days, the fastest orbit of any planet. It's been doing this for billions of years, never complaining, never stopping. There's something admirable about that dedication now. Let's think about Pluto. Poor Pluto, no longer classified as a planet, but still a fascinating world. Pluto is so far from the Sun that sunlight takes 5.5 hours to reach it. When you look at the Sun from Pluto, it just looks like a very bright star, not the warm, glowing disk we see from Earth. The temperature on Pluto is about -370 degrees Fahrenheit. It's a cold, dark, distant place, but it's not alone. Pluto has 5 moons, and the largest, Charon, is so big compared to Pluto that they orbit a point in space between them. They're locked in an eternal dance, always facing each other, never looking away. If you stood on Pluto and looked up, Charon would always be in the same spot in the sky, never rising or setting. That's loyalty, that's commitment, that's a kind of love, even in the coldest, darkest reaches of the solar system. Let's talk about comets. Comets are dirty snowballs, chunks of ice and rock that orbit the sun in long elliptical paths. When a comet gets close to the sun, the ice begins to vaporize, creating a glowing coma around the nucleus, and often a beautiful tail that can stretch millions of miles. Comets are breathtaking to see, and they've inspired awe and sometimes fear in humans for millennia. But here's a calming fact. Most comets are just passing through. They come from the far reaches of the solar system, swing by the sun, and then head back out into the darkness for decades, centuries, or even millennia. They're travelers, wanderers, never staying in one place for long. There's a freedom in that. Some comets visit us regularly. Halley's Comet returns every 75 to 76 years. The last time it visited was 1986, and it will return in 2061. People have been recording sightings of Halley's Comet for over 2,000 years. It's appeared in ancient Chinese records, in Babylonian texts, and it's even depicted in the Bayeux Tapestry from 1066. That same comet, the same object, has been witnessed by countless generations of humans, each one looking up and feeling the same sense of wonder. We're part of that chain, part of that story. Let's think about the asteroid belt, the region between Mars and Jupiter where millions of asteroids orbit the sun. When people picture the asteroid belt, they often think of a dense field of rocks that would be dangerous to fly through. But the reality is much more peaceful. The asteroids are spread out over such a vast area that if you were to fly through the asteroid belt, you probably wouldn't even see another asteroid. Space is so big that even millions of objects can be swallowed up by the emptiness. There's room for everything. There's no need to bump into each other. The universe has space for all of us. Here's something to consider. The light from the sun takes about 8 minutes and 20 seconds to reach Earth. That means when you look at the sun, you're seeing it as it was 8 minutes ago. You're looking into the past. In fact, when you look at anything in space, you're looking into the past because light takes time to travel. The farther away something is, the further back in time you're seeing. When you look at stars, you might be seeing them as they were hundreds, thousands, or even millions of years ago. Some of those stars might not even exist anymore. Their light has been traveling through space for so long that the star itself has already died, but we still see it shining. There's something beautiful and sad about that, like a memory that lingers long after the moment has passed. Now, think about this. Every day, Earth is hit by about 100 tons of dust and sand-sized particles from space. They burn up in the atmosphere as meteors, what we call shooting stars. 100 tons every single day, and we barely notice. That's about 17 dump trucks full of cosmic material. All of that dust was once part of asteroids, comets, maybe even planets that broke apart long ago. It's falling gently onto Earth, becoming part of our world. You've probably breathed in atoms that were once part of a comet. You've probably touched dust that fell from space. We're more connected to the cosmos than we realize. Let's talk about nebulae. Nebulae are giant clouds of dust and gas in space, and they're among the most beautiful objects in the universe. Some nebulae are stellar nurseries, places where new stars are being born. The gas and dust slowly come together under gravity, getting denser and hotter until nuclear fusion ignites and a new star is born. Other nebulae are the remains of dead stars, like the Ring Nebula or the Crab Nebula, where a star has exploded and thrown its outer layers into space, creating a glowing shell of gas that will eventually disperse and become part of new stars and planets. Birth and death, creation and destruction, all happening in slow motion over millions of years. The universe recycles everything. Nothing is wasted. One of the most famous nebula is the Orion Nebula, visible to the naked eye as a fuzzy patch in the sword of Orion the Hunter. It's about 1,300 light-years away, and it's a massive star-forming region. Inside the Orion Nebula, hundreds of baby stars are being born right now. Well, right now, as we see it. Though it actually happened 1,300 years ago, because that's how long the light has taken to reach us. Those stars are young, just a few 100,000 years old, compared to our sun, which is 4.5 billion years old. They're cosmic newborns, and they're surrounded by disks of dust and gas that might be forming planets even as we speak. New worlds are being created all the time. The universe is endlessly creative. Here's a thought that might help you sleep. The universe is expanding. Every galaxy is moving away from every other galaxy. The farther away a galaxy is, the faster it's moving away from us. This isn't because they're traveling through space, but because space itself is expanding, like the surface of a balloon being inflated. What this means is that the universe is getting bigger, more spacious, less crowded. There's more room for everything with every passing second. The universe is making space, creating openness, expanding possibility. You can do that too. You can expand, grow, create space in your own life. Let's continue our peaceful journey through the cosmos, drifting deeper into the wonders of space. Take another slow, deep breath and let yourself relax even more as we explore the universe together. Think about the speed of light. Light travels at 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in just 1 second. Yet even at that incredible speed, light from the nearest star to our Sun, Proxima Centauri, takes 4.2 years to reach us. The universe is so vast that even light, the fastest thing we know, takes years to cross the distances between stars. There's no rush in the universe. Everything happens at its own pace, in its own time. You can take your time to dot. Our Sun is located in one of the spiral arms of the Milky Way galaxy, about 26,000 light-years from the center. We're in a quiet neighborhood, far from the busy galactic core, where stars are packed much closer together. We're in the suburbs of the galaxy, you might say. It's peaceful out here. The nearest star is 4 light-years away, giving us plenty of space, plenty of quiet. Our solar system has been in this calm region for billions of years, and it's been a good place to be. Safe, stable, peaceful. Let's talk about galaxies. There are an estimated 200 billion to 2 trillion galaxies in the observable universe. Each galaxy contains millions, billions, or even trillions of stars. The numbers become so large, they lose meaning. But here's what matters. Each galaxy is an island of stars, separated from other galaxies by vast stretches of mostly empty space. The nearest major galaxy to the Milky Way is the Andromeda Galaxy, and it's 2.5 million light-years away. That's the closest one. Most galaxies are much, much farther. In the grand scheme of things, galaxies are lonely islands floating in an ocean of darkness. But they're not sad about it. They're content, spinning slowly, creating stars, living their long, slow lives. Interestingly, in about 4.5 billion years, Andromeda and the Milky Way will collide. But don't worry, when galaxies collide, the stars don't actually crash into each other. Remember, space is mostly empty. The stars are so far apart that they'll just pass by each other like 2 swarms of fireflies, flying through each other on a summer night. The two galaxies will merge, combining into one larger galaxy. Some scientists have already given it a name, Milkomeda. By the time that happens, the sun will be nearing the end of its life anyway. It's all part of the natural cycle. Change is the only constant, and even galaxies embrace change eventually. Here's something wonderful. Every star you can see with your naked eye is part of our galaxy. Every single one. When you look up at the night sky and see thousands of stars, you're looking at your galactic neighborhood. You're looking at fellow travelers, all of us orbiting the center of the Milky Way together. We're all in this together, all part of the same cosmic family. That's a comforting thought, isn't it? Let's think about the age of light. When you look at a star that's 100 light years away, you're seeing light that left that star 100 years ago. You're seeing the star as it was in 1925. If aliens on a planet orbiting that star were looking at Earth right now with a powerful enough telescope, they would see Earth as it was in 1925. They'd see a world without television, without computers, without space travel. They'd see a younger Earth. The universe doesn't have one present moment. It has infinite present moments, depending on where you're standing and what you're looking at. Time is more fluid than we usually think. Now, picture the Voyager spacecraft. Voyager 1 and Voyager 2 were launched in 1977, almost 50 years ago. They've traveled farther from Earth than any other human-made objects. Voyager 1 is now in interstellar space beyond the influence of the sun, traveling through the space between the stars. It's about 14.5 billion miles from Earth. If you sent a radio signal to Voyager 1 right now, traveling at the speed of light, it would take over 22 hours to get there. Voyager is so far away, so alone, but it keeps going. It's still sending back signals, faint whispers from the edge of the solar system. Its power is running low, and in a few years, it will go silent, but it will keep traveling. In about 40,000 years, Voyager 1 will pass within about 1.5 light years of a star in the constellation Ursa Minor. It will be a visitor from Earth, carrying a golden record with sounds and images from our planet. A message in a bottle for anyone who might find it. It's a lonely journey, but there's poetry in it. Let's talk about the cosmic microwave background radiation. This is the afterglow of the Big Bang. The light from the moment the universe became transparent, about 380,000 years after the beginning. This light has been traveling through space for over 13 billion years, and it's still here. It fills all of space, coming from every direction. If you could see microwave light with your eyes, the entire sky would glow with this faint, uniform light. It's the oldest light in the universe, a fossil from the beginning of everything. Scientists study it to learn about the early universe, but there's something deeply peaceful about it too. It's a reminder that the universe has been here for a very long time, and it will be here for a very long time to come. We're just passing through, and that's okay. The universe started with the Big Bang, an expansion of space from an infinitely small, infinitely dense point. But it wasn't an explosion into empty space. It was space itself coming into existence and expanding. Before the Big Bang, there was no space, no time, no matter, no energy. There was nothing, and then there was everything. It's hard to wrap your mind around that, isn't it? Maybe you don't need to understand it completely. Maybe it's enough to know that the universe began, and here we are, part of it, experiencing it from the inside. You don't need to have all the answers. You can rest in the mystery. Here's something that might ease your mind. The universe has no center and no edge. When space expands, it doesn't expand into anything. It just expands. Every point in the universe is equally valid. You're not on the edge of anything. You're not far from the center. You are the center from your perspective. Everyone and everything is at the center of their own observable universe. You're exactly where you need to be. Let's visit Neptune, the eighth and farthest planet from the Sun. Neptune is a beautiful blue color because of the methane in its atmosphere, which absorbs red light and reflects blue. Neptune is so far from the Sun that it takes 165 Earth years to complete one orbit. It was discovered in 1846, and it didn't complete its first full orbit since discovery until 2011. Imagine that. A year on Neptune is longer than a human lifetime. Time moves differently depending on where you are. What feels long to us is just a moment to Neptune. Everything is relative. Your problems, your worries, they're significant to you. But in the grand scheme of the universe, they're tiny and temporary. That's not to diminish them, but to put them in perspective. The universe has time. You have time. Neptune has the fastest winds in the solar system, with speeds reaching up to 1,200 miles per hour. These winds blow in the opposite direction of the planet's rotation, and scientists aren't entirely sure why. Neptune is a dynamic, active world, even though it's so far from the Sun's warmth. It has its own internal heat source, radiating more energy than it receives from the Sun. Neptune is a reminder that even in cold, distant places, there's energy, there's activity, there's life of a sort. You don't need external validation or warmth to have your own fire inside. Let's think about Uranus for a moment. Uranus is unique because it rotates on its side. Its axis is tilted 98 degrees, which means it essentially rolls around the Sun like a ball. Scientists think that a massive collision early in its history knocked it over. Each pole gets 42 years of continuous sunlight, followed by 42 years of darkness. Can you imagine? 42 years of summer, then 42 years of winter. It's the most extreme seasonal variation in the solar system. But Uranus keeps going, rolling along its orbit, unbothered by its unusual orientation. Sometimes life knocks us sideways, and we have to find a new way to move forward. Uranus is proof. Now let's talk about something fascinating. The International Space Station orbits Earth every 90 minutes. That means the astronauts on board see 16 sunrises and 16 sunsets every single day. Imagine that. Every 90 minutes, day turns to night, and night turns to day. The astronauts have to create their own sense of time because the natural rhythm of day and night is completely disrupted. They live in a constant cycle of light and dark, always moving, always changing. And yet, they adapt. Humans are incredibly adaptable. We can find peace and routine even in the most unusual circumstances. Astronauts in space often report a profound experience called the overview effect. When they look down at Earth from space, they see the planet as a whole, a beautiful blue marble floating in the blackness. They see no borders, no divisions, just one interconnected world. They see the thinness of the atmosphere, that fragile layer that protects all life. They see the unity of everything. Many astronauts say it changes them permanently, gives them a sense of perspective and peace that stays with them forever. We can't all go to space, but we can try to see Earth the way they do. We're all on this planet together, sharing the same air, the same water, the same sunlight. We're all connected. Let's drift to the edge of the solar system and think about the Oort cloud. This is a theoretical sphere of icy objects that surrounds the solar system, extending from about 2,000 times the distance from the Sun to Pluto, all the way out to about 100,000 times that distance. It's the source of long-period comets, those comets that take hundreds or thousands of years to orbit the Sun. The Oort cloud is so far away that objects there are barely held by the Sun's gravity. There on the edge, almost free, but not quite. It's a frontier, a boundary between our solar system and interstellar space. There's something romantic about boundaries, about edges. They're places of possibility where one thing ends and another begins. Here's a calming fact. The universe is mostly empty space. If you took all the matter in the universe and spread it out evenly, there would only be about 5.5 atoms per cubic meter. That's almost nothing. The universe is more emptiness than anything else. Even atoms themselves are mostly empty space. If the nucleus of an atom were the size of a marble, the electrons would be orbiting about half a mile away. You are mostly empty space. Your body is mostly nothing. There's a lightness to that realization. You don't have to carry so much weight. You're already light. You're already free, in a way. Let's talk about brown dwarfs. Brown dwarfs are objects that are bigger than planets, but smaller than stars. They're not massive enough to sustain hydrogen fusion like real stars. So they just glow dimly with leftover heat from their formation. They're failed stars, in a sense, but they're still fascinating. They're their own thing, existing in the space between planet and star, belonging to neither category completely. There's something relatable about that. Not everything fits into neat categories. Not everything has to be one thing or another. You can be in between. You can be your own thing. That's perfectly fine. Think about red dwarf stars. These are the most common type of star in the universe, making up about 70% of all stars. They're small, cool, and they burn their fuel very slowly. A red dwarf can live for trillions of years, far longer than the current age of the universe. In fact, every red dwarf that has ever been born is still alive today. None of them have had time to die yet. They're patient stars, taking their time, burning slowly and steadily. They're not flashy or dramatic like giant blue stars that burn bright and die young. Red dwarfs are the tortoises of the cosmic race, and they're winning by lasting. There's wisdom in patience, in taking your time, in burning slowly rather than burning out. Let's visit Titan, the largest moon of Saturn. Titan is the only moon in the solar system with a thick atmosphere. And it's the only place besides Earth where we found stable bodies of liquid on the surface. But these aren't lakes of water. They're lakes of liquid methane and ethane. Titan has a complete liquid cycle, like Earth's water cycle, but with methane. It rains methane. Rivers of methane flow into seas of methane. It's a familiar process happening in an alien way. Titan shows us that nature finds patterns, cycles, rhythms, even in the strangest environments. The universe likes patterns. There's comfort in that. Titan's atmosphere is so thick and hazy that you can't see the surface from space. When you look at Titan, you just see an orange blur. But landers we've sent there have shown us a world that looks surprisingly familiar in some ways. There are river valleys, coastlines, islands. It's cold, minus 290 degrees Fahrenheit, and the lakes are liquid methane, but the shapes are familiar. It's a reminder that even in alien places, there are echoes of home. Now, let's talk about Enceladus, another moon of Saturn. Enceladus is small, only about 300 miles in diameter, but it's one of the most exciting places in the solar system. Underneath its icy surface, there's a global ocean of liquid water. We know this because Enceladus has geysers at its south pole that spray water into space. The Cassini spacecraft flew through these geysers and tasted the water. It found salt, organic molecules, and evidence of hydrothermal activity on the ocean floor. Enceladus might have all the ingredients for life. There might be living things swimming in that dark ocean beneath the ice. We don't know yet, but the possibility is there. The universe might be full of life, hidden away in unexpected places. We're not alone. We might never be alone. Let's consider Europa, a moon of Jupiter. Europa is another icy world with an ocean beneath its surface. And that ocean might contain twice as much water as all of Earth's oceans combined. The surface of Europa is covered in cracks and ridges, and it's relatively young in geological terms, which means the ice is constantly being renewed. Something is moving that ice, and that something is probably the ocean beneath. The tidal forces from Jupiter heat Europa's interior, keeping the ocean liquid despite being so far from the sun. Where there's liquid water, there's possibility. Europa is another place we might find life someday. The universe is generous with the ingredients for life. It scatters them widely. Here's something that might surprise you. The largest volcano in the solar system isn't on Earth. It's Olympus Mons on Mars, which we mentioned earlier. But did you know that the largest canyon in the solar system is also on Mars? It's called Valles Marineris, and it's about 2,500 miles long, 400 miles wide, and up to 4.5 miles deep. To put that in perspective, it would stretch across the entire United States from coast to coast. The Grand Canyon would be just a small scratch compared to Valles Marineris. Mars is a world of extremes, of grand geological features shaped over billions of years. It's a quiet world now, with no active volcanoes and no flowing water, but it bears the scars of a more active past. There's a dignity in that, in bearing witness to your own history, in carrying the marks of what you've been through. Let's slow down and think about the sun again. The sun is powered by nuclear fusion, the process of combining hydrogen atoms into helium atoms, releasing enormous amounts of energy in the process. This happens in the core of the sun, where the temperature is about 27 million degrees Fahrenheit, and the pressure is immense. But here's what's interesting. The energy created in the core doesn't immediately leave the sun. It takes thousands to millions of years for that energy to work its way from the core to the surface, because it keeps getting absorbed and re-emitted by atoms along the way. By the time the light you see reaches the surface of the sun, it's ancient. It was created long before human civilization existed. And then it takes 8 minutes to travel from the sun to Earth. The sunlight touching your face right now is ancient light that has finally reached you after an incredibly long journey. You are being touched by the deep past. Asterisk, think about solar eclipses. A solar eclipse happens when the moon passes between the Earth and the sun, blocking the sun's light. The incredible thing about solar eclipses is that they're only possible because of an amazing cosmic coincidence. The sun is about 400 times larger than the moon, but it's also about 400 times farther away from Earth than the moon. This means they appear to be the same size in our sky. This coincidence won't last forever. The moon is slowly moving away from Earth, and in about 600 million years, it will be too far away to completely cover the sun. There will be no more total solar eclipses. We're living in the right time to see them. We're lucky to be here now, to witness this perfect alignment. It's a gift. During a total solar eclipse, day turns to night in the middle of the day. The temperature drops. Animals get confused. Stars come out. And if you're in the path of totality, you can see the sun's corona, the outer atmosphere, glowing around the dark disk of the moon. People who have seen a total solar eclipse often describe it as a spiritual experience, something that moves them deeply. It's a reminder that we're part of something larger, that the universe can still surprise us, still show us beauty that takes our breath away. Let's talk about meteor showers. At certain times of year, Earth passes through streams of debris left behind by comets. As these tiny particles hit Earth's atmosphere at high speed, they burn up, creating streaks of light across the sky. We call them shooting stars, though they're not stars at all. During a good meteor shower, you might see dozens or even hundreds of meteors per hour. There's something magical about lying on your back and watching the sky, waiting for the next streak of light. It's patient work. You can't rush it. You just have to watch and wait. And when you finally see a meteor, there's a little burst of joy. The universe has given you a gift, a moment of beauty. You can make a wish if you want, though the meteor doesn't really care. It's just a piece of dust burning up in the atmosphere. But the wish matters to you, and that's enough. The most famous meteor shower is probably the Perseids, which happens every August. The Perseids are debris from the comet Swift-Tuttle, which orbits the Sun every 133 years. Every August, Earth passes through the trail of dust that Swift-Tuttle left behind, and we get a show. It's been happening for thousands of years, and it will keep happening for thousands more. It's a reliable annual event. The universe keeps its appointments. You can count on it. Here's a thought to drift off to sleep with. There are things in the universe we haven't discovered yet. Planets we haven't found. moons we don't know about, maybe even forms of life we can't imagine. The universe still has secrets. There are still mysteries waiting to be solved. And that's wonderful. Life would be boring if we knew everything. The universe keeps us curious, keeps us wondering, keeps us looking up. Tomorrow, someone might discover something new, something that changes how we see the cosmos. And you'll be here to hear about it, to marvel at it, to add it to your understanding of the universe. There's always more to learn, and there's no rush. The universe will wait for you. Let's continue drifting through the peaceful expanse of space, discovering more gentle wonders that will carry you into restful sleep. Breathe slowly, relax deeply, and let the cosmos embrace you. Think about the concept of a light year. A light year isn't a measure of time, it's a measure of distance. It's the distance light travels in 1 year, which is about 5.88 trillion miles. When we say a star is 10 light years away, we mean it would take light 10 years to travel from that star to us. The distances in space are so vast that we had to invent new ways to measure them. Miles and kilometers just aren't enough. The universe is teaching us to think bigger, to expand our sense of scale. And in doing so, it reminds us that our everyday problems, while real and important to us, are incredibly small in the grand cosmic scheme. There's freedom in that perspective. Let's visit some interesting stars. Betelgeuse is a red supergiant star in the constellation Orion. It's one of the largest stars we know, so big that if you placed it where our sun is, it would extend past the orbit of Mars. Betelgeuse is near the end of its life, and it could explode as a supernova at any time. When we say any time in cosmic terms, that means it could happen tomorrow, or it could happen 100,000 years from now. When it does explode, it will be visible during the day for weeks, and it will be as bright as the full moon at night. It will be spectacular. But here's the thing, Betelgeuse is 600 light years away. If it exploded today, we wouldn't know for 600 years. And if we see it explode tomorrow, it actually happened 600 years ago. We're always looking at the past when we look at the stars. The present moment we experience here on Earth is uniquely ours. The universe doesn't have one universal now. There's a star called VY Canis Majoris, which is one of the largest known stars. It's a red hypergiant, and it's so big that if you flew around it at the speed of light, it would take 6 hours to complete one orbit. 6 hours at the speed of light. That's almost incomprehensibly large. Yet, this enormous star is just one of billions in our galaxy. It's extraordinary, but it's not unique. The universe produces wonders constantly, casually, without fanfare. There are probably thousands of stars just as large that we haven't even discovered yet. The universe is abundant with magnificence. Now, let's think about smaller stars. Proxima Centauri, the closest star to our Sun, is a red dwarf about 1/7 the diameter of the Sun. It's small and cool, barely visible to the naked eye, even though it's the closest star. Proxima Centauri has at least 2 planets that we know of, and one of them, Proxima Centauri b, is in the habitable zone where liquid water could exist. It's about 4.2 light-years away. That's our closest stellar neighbor, and it might have a planet with conditions suitable for life. We don't know if there's actually life there, but the possibility exists. The closest star system to us might be home to living things, looking up at their sky, perhaps wondering if they're alone, just like we do. Let's talk about binary star systems. About half of all stars are actually part of binary or multiple star systems, where 2 or more stars orbit around their common center of mass. Imagine living on a planet in a binary star system. You might have 2 suns in your sky. You might never have true night, or you might have complex patterns of light and shadow as your suns move around each other. Sunset would mean one sun going down while the other is still up. Some binary stars are so close they actually touch, sharing their outer layers of gas. They're locked in an eternal embrace, 2 stars becoming almost one. It's a different way of existing, neither better nor worse than our single sun, just different. The universe has room for all arrangements, all possibilities. Here's something peaceful to consider. Astronomers have found planets orbiting binary stars. These are called circumbinary planets, and they orbit both stars together. The most famous example is Kepler 16b, a gas giant about the size of Saturn orbiting 2 stars that eclipse each other. If you stood on a moon of that planet, you would see 2 suns setting together. Just like the famous twin sunset scene from a certain science fiction movie. Life imitates art, or perhaps art predicted life. The universe is more creative than our imaginations. Let's think about the concept of habitable zones. Every star has a habitable zone, sometimes called the Goldilocks zone, where the temperature is just right for liquid water to exist on a planet's surface. For our Sun, that zone includes Earth and extends from about where Venus is to about where Mars is. But habitable zones aren't guarantees of life. Venus is in the habitable zone, but it's a hellish world with a runaway greenhouse effect. Mars is barely in the habitable zone, but it's cold and dry. Earth is right in the middle, and it has life. We got lucky, or maybe life is resilient and adaptable, and we're just the form it takes here. Other planets might have life that's nothing like ours, living in conditions we'd consider impossible. Asterisk, there's a concept called panspermia, the idea that life might spread from planet to planet, or even from star system to star system, carried on asteroids or comets. When a large asteroid hits a planet, it can blast rocks into space. Some of those rocks might escape the planet's gravity and eventually land on another planet. Scientists have found meteorites on Earth that came from Mars. If there was ever life on Mars, could it have hitched a ride to Earth? Are we, in some distant sense, Martians? Or did life start on Earth and spread to Mars? We don't know, but it's a reminder that we might be more connected to the cosmos than we realize. Life might be a cosmic phenomenon, not just a terrestrial one. Let's slow down and think about the atmospheres of planets. Here's something fascinating. The Earth's magnetic field protects us from solar wind, a stream of charged particles constantly flowing out from the sun. Without the magnetic field, the solar wind would strip away our atmosphere over time, the way it did to Mars. Mars used to have a thicker atmosphere and a magnetic field, but the field shut down billions of years ago, and the atmosphere gradually eroded away. Earth's magnetic field is generated by the motion of molten iron in the outer core. It's constantly moving, swirling, creating electric currents that generate the magnetic field. The field isn't static. It moves and shifts. The magnetic poles drift over time, and every few 100,000 years, the field flips completely. North becomes south, and south becomes north. We don't know exactly when the next flip will happen, but it's coming eventually. The universe is always changing, always in motion. Nothing stays the same forever. And that's natural. The magnetic field does something else beautiful. When solar wind particles do make it through and interact with our atmosphere near the poles, they create auroras, the northern and southern lights. Charged particles from the sun collide with oxygen and nitrogen in the atmosphere, making them glow. Oxygen produces green and red light. Nitrogen produces blue and purple. The result is shimmering curtains of light dancing across the sky, visible near the Arctic and Antarctic. People who live in the far north or far south get to see this display regularly. It's the sun and earth interacting, creating art together. The universe is beautiful, not just in the grand sense of galaxies and nebulae, but in the small interactions, the moments when different parts of the cosmos touch and create something lovely. Let's talk about time dilation, a concept from Einstein's theory of relativity. Time doesn't pass at the same rate everywhere. If you're moving very fast, time slows down for you relative to someone who's standing still. If you're near a massive object like a black hole, time also slows down for you. Astronauts on the International Space Station age slightly slower than people on Earth. because they're moving fast and they're slightly farther from Earth's gravity. The difference is tiny, just a few milliseconds over months in space, but it's real. Time is flexible. Your experience of time is not the same as someone else's. We each have our own river of time, flowing at its own pace. There's something comforting about that. You have your own time. You don't have to keep up with anyone else's clock. Imagine this. If you could travel at the speed of light, time would stop for you completely. From your perspective, the journey would be instantaneous. You could travel across the entire galaxy in no time at all, subjectively. But for everyone else, watching you go, you would be traveling for thousands of years. This is the universe's way of protecting the speed of light as the ultimate speed limit. You can't experience yourself going faster than light because time itself adjusts to prevent it. The universe has rules, but they're stranger and more flexible than we usually think. Here's a calming thought about infinity. The universe might be infinite, or it might be finite, but unbounded, like the surface of a sphere. If you travel in one direction long enough on a sphere, you eventually come back to where you started. The universe might be like that, curved in a way we can't visualize because we're three-dimensional beings, living in a space that might curve through a fourth spatial dimension. Or the universe might just go on forever, infinite space filled with infinite galaxies. Either way, there's enough universe. There's enough room. There's enough time. You don't have to worry about running out. Let's visit some of the moons of the outer solar system. Io, the innermost of Jupiter's large moons, is the most volcanically active body in the solar system. It has hundreds of active volcanoes constantly erupting, spewing sulfur and sulfur dioxide across its surface. Io is caught in a gravitational tug of war between Jupiter and the other large moons. And this constant squeezing and stretching heats Io's interior, melting rock and driving the volcanic activity. Io is never at rest. It's always changing, always active. But it's been this way for billions of years. It's found a kind of dynamic equilibrium. Activity doesn't have to mean chaos. You can be active and still be stable. Ganymede, another moon of Jupiter, is the largest moon in the solar system. It's bigger than the planet Mercury. Ganymede has its own magnetic field, the only moon known to have one. Underneath its icy surface, Ganymede probably has several layers of ice and water, with a liquid ocean sandwiched between layers of different types of ice. It's a complex world, a moon that could almost be a planet in its own right. Size isn't everything, but Ganymede has size and complexity and mystery. It's a world worth studying, worth understanding. Callisto, the outermost of Jupiter's 4 large moons, is ancient and heavily cratered. Its surface is one of the oldest in the solar system, barely changed in billions of years. Callisto has been battered by impacts, and it bears the scars, but it endures. It's a witness to the history of the solar system. Every crater tells a story of a collision, a moment of violence frozen in ice. But Callisto is still here. It survived. There's strength in endurance, in lasting, in bearing witness. Let's think about Saturn's moon, Hyperion. Hyperion is irregularly shaped, like a giant sponge or a potato. It's covered in deep craters, and it tumbles chaotically as it orbits Saturn. Most moons rotate in a regular, predictable way, but Hyperion doesn't. Its rotation is chaotic, literally. You can't predict which way it will be facing from one day to the next. It's unpredictable, but it's still in a stable orbit. You don't have to have everything figured out. You don't have to rotate smoothly and predictably. You can tumble, you can be irregular, and you can still be okay. Here's something amazing. Saturn's moon, Iapetus, has two faces. One hemisphere is bright and icy, while the other is dark and covered in some kind of reddish-brown material. The difference is stark. It's like two different moons stitched together. Scientists think the dark material comes from another moon, Phoebe, which orbits farther out. Dust from Phoebe drifts inward and coats one side of Iapetus. Over time, that dark material absorbs more heat from the sun, causing ice to sublimate away, leaving behind more dark material in a runaway process. Iapetus shows us that you can have two sides, two aspects, light and dark, and still be one whole thing. We all have different sides. That's natural now. Let's drift to the edge of the solar system again and think about the Kuiper Belt. This is a region beyond Neptune filled with icy bodies, including dwarf planets like Pluto. The Kuiper Belt is like the asteroid belt, but farther out and much larger. It's a remnant from the formation of the solar system, a disk of material that never quite coalesced into planets. The objects there are cold, ancient, and pristine, preserving a record of what the early solar system was like. Scientists call them time capsules. They've been frozen in place for 4.5 billion years, waiting for us to visit them and learn their secrets. The New Horizons spacecraft flew by Pluto in 2015, and it's now exploring other Kuiper Belt objects. We're learning about our origins by visiting the frozen frontier. There's an object in the Kuiper Belt called Arrokoth, which New Horizons visited in 2019. Arrokoth is a contact binary, two objects that gently merged together early in the solar system's history. It's shaped like a snowman, two lobes connected by a narrow neck. Arrokoth formed by a gentle collision, not a violent one. The two objects drifted together slowly and stuck. It's a reminder that not all collisions are destructive. Sometimes things come together gently and create something new, Let's think about the future of the Sun right now. The Sun is middle-aged, about 4.5 billion years old, with another 5 billion years to go. But it won't stay the way it is forever. As the Sun ages, it will gradually get hotter and brighter. In about 1 billion years, it will be hot enough that Earth's oceans will start to evaporate. In about 5 billion years, the Sun will run out of hydrogen in its core and will start burning helium. It will swell up, becoming a red giant, possibly engulfing Mercury and Venus, and making Earth uninhabitable if it isn't engulfed as well. Eventually, the Sun will shed its outer layers, creating a beautiful planetary nebula, and the core will collapse into a white dwarf, a small, dense star about the size of Earth. The white dwarf will slowly cool over trillions of years, eventually becoming a cold, dark, black dwarf. Though the universe isn't old enough yet for any black dwarfs to exist. The Sun will die, but it will do so gracefully, returning its material to space, contributing to the next. Think about the pale blue dot. In 1990, the Voyager 1 spacecraft, having completed its primary mission, turned its camera back toward Earth from a distance of about 4 billion miles. Earth appeared as a tiny speck of light, less than a single pixel in the image. The astronomer Carl Sagan wrote beautifully about this image, calling Earth a pale blue dot, a mote of dust suspended in a sunbeam. Everything that has ever happened in human history happened on that tiny speck. Every person you've ever known, every story ever told, every empire that rose and fell, all of it on that one small point of light. From that distance, you can't see borders or nations or differences. You just see home, one small, fragile world in the vastness of space. It's humbling and beautiful at the same time. It reminds us to be kind to each other and to our planet, because that pale blue dot is all we have. Let's think about what exists beyond our observable universe. The observable universe is everything we can see, everything whose light has had time to reach us since the Big Bang. But the universe doesn't end where we can't see it anymore. There's likely much more universe beyond what we can observe, perhaps infinitely more. Out there, beyond the horizon of our observation, there might be other galaxies, other clusters, other superclusters continuing on forever. Or the universe might curve back on itself somehow. We don't know. We may never know. And that's all right. Some mysteries don't need to be solved. Some questions don't need answers. You can rest in the unknown. Here's something to consider about dark matter and dark energy. The matter we can see, all the stars and planets and galaxies and nebulae, makes up only about 5% of the universe. Another 27% is dark matter, an invisible form of matter that we can only detect through its gravitational effects. And the remaining 68% is dark energy, a mysterious force causing the expansion of the universe to accelerate. We don't know what dark matter or dark energy actually are. They're called dark because we can't see them, but they're the dominant components of the universe. Most of the universe is invisible to us. We're living in a reality where we can only perceive a tiny fraction of what actually exists. There's so much more out there, hidden, mysterious, waiting to be understood. The universe is far stranger than we imagine, and that's exciting, not frightening. Dark matter doesn't emit, absorb, or reflect light. It doesn't interact with electromagnetic radiation at all. But it has mass, and therefore, it has gravity. We know dark matter exists because we can see its gravitational effects on visible matter. Galaxies rotate in ways that don't make sense based on the visible matter alone. There must be more mass there, holding things together, and that mass is dark matter. It's like the universe is mostly made of something we can't see, can't touch, can't directly detect, but it's holding everything together. There's poetry in that. The invisible foundation that keeps everything from flying apart. Dark energy is even more mysterious. It's the force causing the expansion of the universe to accelerate. The universe isn't just expanding, it's expanding faster and faster over time. Eventually, billions of years from now, distant galaxies will be moving away from us faster than the speed of light because space itself is expanding. They won't disappear suddenly, but they'll gradually redshift out of visibility. Their light stretched into longer and longer wavelengths until it's undetectable. In the far future, beings living in our galaxy will look out and see nothing but darkness beyond their local group of galaxies. They won't know that there were once billions of other galaxies visible. The universe will have changed, but that won't happen for a very, very long time. We're living in a golden age, a time when the universe is old enough to have formed complex structures, but young enough that we can still see most of it. We're here at the right time. Let's talk about the heat death of the universe, but in a calming way. Based on what we know now, the universe will continue expanding forever. Stars will eventually use up all available gas and stop forming. Existing stars will burn out. White dwarfs will cool into black dwarfs. Black holes will slowly evaporate through Hawking radiation. Eventually, in an unimaginably distant future, the universe will reach a state of maximum entropy where everything is the same temperature, spread out evenly with no energy available to do work. This is called the heat death. It sounds bleak, but it's so far in the future that it's almost meaningless. We're talking about 10 to the 100 years from now, a 1 followed by 100 zeros. For comparison, The universe is currently only about 10 to the 10 years old. The universe has an incredibly long life ahead of it, and so much will happen between now and then. Stars will shine for trillions of years. Life might spread to countless worlds. Civilizations might rise that we can't even imagine. The ending is so distant that it doesn't diminish the journey. What matters is the time we have, the experiences we gather, the beauty we witness along the way. Here's a comforting thought about gravity. Gravity is the weakest of the four fundamental forces, but it's the one that shapes the large-scale structure of the universe. Gravity pulled gas together to form the first stars. It gathered stars into galaxies and galaxies into clusters. Gravity created the cosmic web, that beautiful filamentary structure of galaxy clusters connected by strands of matter with vast voids in between. Gravity is patient and persistent. It works slowly over millions and billions of years, but it gets the job done. It creates order out of chaos. It builds structures. It brings things together. There's something reassuring about gravity, this gentle, persistent force that holds everything in place, that keeps the moon orbiting Earth, that keeps Earth orbiting the sun, that keeps you grounded right where you are. Let's think about neutron stars. When a massive star explodes as a supernova, the core can collapse into a neutron star. An object so dense that a teaspoon of neutron star material would weigh about 1 billion tons. Neutron stars are typically only about 12 miles across, but they contain more mass than the sun. They're the densest objects in the universe besides black holes. Many neutron stars spin rapidly, sometimes hundreds of times per second, and they emit beams of radiation from their magnetic poles. If those beams sweep across Earth, we detect pulses of radiation, and we call these objects pulsars. Pulsars are like cosmic lighthouses, sweeping their beams around and around with incredible precision. Some pulsars are so regular that they rival atomic clocks in their accuracy. They're nature's most precise timekeepers, even in the chaos of a stellar explosion. Nature creates something precise and beautiful. There's a pulsar called PSRJ 1748-2446 that rotates 716 times per second. 716 rotations every single second. The surface of this neutron star is moving at about 1/4 of the speed of light. It's almost incomprehensible, but there it is, spinning away, a remnant of a dead star, still fascinating us, still teaching us about physics, still being useful. Even in death, stars have purpose. Let's talk about gravitational waves. When two black holes or neutron stars orbit each other and eventually merge, they create ripples in the fabric of space-time itself. These ripples spread out at the speed of light, stretching and squeezing space as they pass. In 2015, scientists detected gravitational waves for the first time using an instrument called LIGO. They heard the chirp of two black holes merging over 1 billion light years away. They heard space-time ringing like a bell. It was a sound from the universe itself, a confirmation of Einstein's predictions from a century earlier. We can now listen to the universe in a new way. We can hear collisions, mergers, cataclysms happening in distant galaxies. The universe has music, and we've learned how to hear it. Gravitational waves travel through everything. Right now, gravitational waves from distant cosmic events are passing through you, gently stretching and squeezing the space you occupy. The effect is infinitesimally small, far too small to feel, but it's happening. You're being touched by events that happened millions or billions of years ago in galaxies far away. You're connected to the cosmos in ways you can't even perceive. The universe is always interacting with you, always passing through you, always including you in its vast dance. Let's slow down and think about exoplanets. Planets orbiting stars other than the Sun. The first exoplanet orbiting a Sun-like star was discovered in 1995. Since then, we've discovered thousands of them. We now know that planets are common. Most stars have planets. There are probably more planets in the galaxy than there are stars. Some of these planets are gas giants like Jupiter. Others are rocky worlds like Earth. Some orbit in the habitable zones of their stars. A few might even have conditions suitable for life as we know it. We're living in a time of discovery, learning that the galaxy is full of worlds, each one unique, each one a possibility. There's a star system called TRAPPIST-1, about 40 light-years away, with 7 Earth-sized planets, 3 of them in the habitable zone. These planets are close together, so close that if you stood on the surface of one, the others would appear larger in your sky than the moon appears from Earth. Imagine looking up and seeing multiple planets, some of them possibly habitable, hanging in the sky. What would it be like to live in such a system? What civilizations on different planets eventually meet? Would they be friends or rivals? We don't know if there's life on any of those planets, but the potential is there. The universe is full of possibilities. NASA's Kepler Space Telescope, during its mission, discovered thousands of exoplanets by watching stars and detecting the tiny dips in brightness when a planet passes in front of them. It taught us that planets are everywhere, that solar systems come in all configurations, that nature is endlessly creative. There are planets orbiting binary stars. There are planets in the habitable zones of red dwarfs. There are super-Earths and mini-Neptunes, and planets unlike anything in our own solar system. Every star system is an experiment, a unique combination of initial conditions that leads to a unique outcome. The universe doesn't repeat itself. Every world is original. Let's think about the search for extraterrestrial intelligence. For decades, scientists have been listening to the sky, hoping to detect radio signals from other civilizations. So far, we haven't heard anything conclusive. The silence is called the Fermi paradox, named after a physicist, Enrico Fermi, who asked, "Where is everybody?" If the galaxy is full of stars and planets, and if life is common, why haven't we heard from anyone? There are many possible answers. Maybe life is rare. Maybe intelligence is rare. Maybe civilizations destroy themselves before they become detectable. Maybe they're out there, but we're not listening in the right way or at the right frequencies. Maybe they're so different from us that we wouldn't recognize their signals. Or maybe we're just early. Maybe we're among the first civilizations to arise in the galaxy, and the others are still to come. We don't know. But the search continues. Every night, radio telescopes listen to the stars, hoping to catch a whisper from someone else, another voice in the cosmic wilderness. And whether we find anyone or not, the search itself is meaningful. It's an expression of hope, of curiosity, of the desire to connect. Even if we never find other intelligent life, we're not alone. We have each other. We have this planet teeming with millions of species, each one a marvel of evolution. We have consciousness, the ability to wonder, to question, to look up at the stars and ask why. That's a gift. That's precious. You're part of a species that looks outward, that explores, that dreams of distant worlds. That's something to be proud of. Here's a beautiful thought as we near the end of our journey. The atoms in your body are ancient. They're billions of years old, forged in stars, scattered by supernova, gathered into the cloud that formed our solar system, incorporated into Earth, cycled through the air and water and soil, taken up by plants, eaten by animals, and eventually becoming part of you. You're temporary, but the atoms that make you up are nearly eternal. After you're gone, those atoms will continue on, becoming part of other things, other beings, returning to the Earth, perhaps eventually returning to space. You're borrowing these atoms for a little while, using them to experience the universe, to think and feel and dream. And when you're done, you'll return them and they'll continue their journey. Nothing is truly lost. Everything is transformed. You're part of an endless cycle of creation and transformation that goes back to the beginning and will continue long after you're gone. The universe is 13.8 billion years old, and it will last for trillions upon trillions of years. In the vast timeline of the cosmos, your life is just a brief moment, a single heartbeat. But in that moment, you get to experience everything. You get to see sunsets and stars. You get to love and laugh. You get to learn about the universe, to understand your place in it. You get to be aware, to be conscious, to be alive. That's extraordinary. In a universe that's mostly empty space and lifeless rock, you're a pocket of complexity and awareness. You matter. Your experience matters. The universe is experiencing itself through you. As you drift off to sleep tonight, know that you're safe. You're on a planet that's been here for 4.5 billion years, orbiting a star that will shine for billions more. You're protected by an atmosphere, warmed by the sun, held by gravity. The moon is up there, keeping watch, pulling the tides, lighting the night. The stars are shining, distant and eternal. The galaxy is slowly turning, carrying you through space. And the universe itself, vast and ancient and mysterious, surrounds you completely. You're part of it all. You belong here. You're home. Rest now. Let go of your worries. They're so small compared to the vastness of space and time. Let the universe hold you. Let the gentle rhythms of the cosmos lull you to sleep. The stars will still be there tomorrow. The sun will rise. The moon will wax and wane. The seasons will change. The universe will continue its ancient dance, and you'll wake refreshed, ready to experience another day of this brief, beautiful, miraculous existence. Sleep well, dream of stars, and know that you're exactly where you're meant to be, in this moment, in this universe, under this sky. Everything is as it should be. You're safe. You're loved by the cosmos. You're made of stardust, and to stardust you'll return, but not yet. For now, just rest. Just breathe. Just be. The universe is patient. It's been waiting 13.8 billion years for you to exist, for you to open your eyes and look up in wonder. It can wait a little longer while you sleep. It'll still be there when you wake, full of mystery and beauty and endless possibilities. For now, let yourself float among the stars in your dreams. Let the gentle voice of the cosmos sing you to sleep. Good night. Sleep peacefully. The universe is watching over you, as it always has, as it always will. You're part of something vast and eternal and infinitely beautiful. Rest in that knowledge. Rest in that peace. Rest in the gentle embrace of the cosmos. And with that, our journey through the stars comes to a close. May you sleep deeply, dream sweetly, and wake tomorrow with a renewed sense of wonder at this magnificent universe we call home. If you enjoyed this peaceful journey through the cosmos, please consider subscribing to our channel for more relaxing stories that will help you drift into restful sleep. Like this video, If it helped calm your mind, and share it with anyone who might need a peaceful night's rest. Leave a comment telling us which astronomical fact was your favorite, or what topic you'd like us to explore next. Your support helps us create more content to guide you toward better sleep and peaceful dreams. Remember, the universe is vast, but you are an important part of it. Every star you see is a reminder that you're connected to something far greater than yourself. Take that peace with you, not just into your dreams tonight, but into your waking life tomorrow. Until next time. Keep looking up, keep wondering, and keep finding peace in the beauty of the cosmos. Sweet dreams, and may the stars watch over you always. Good night.